let me start. I will give my introduction at the last, probably. And since Abhishek has already given a brief introduction about myself, I think that would do. So let's jump into uh, the presentation. Yeah. So yeah, hope my screen is visible, guys.
Yes.
Okay. Okay, guys. So the talk actually, when I was in discussion with Anuj and Abhishek regarding this, so I was very much skeptical, like whether this talk will be best match for a group which is totally dedicated to Android. But what I thought was like, why not do this kind of talks? Because this kind of talks are quite familiar outside India, I would say. But in India, you will find a very less community, or probably very few guys who are delivering some like their learnings as they go and towards the software craftsmanship. So what I thought was, why not give it a try, and let's see if this fits well into this community. And also, like we have a online environment where everything is virtual and like hands-on is very much on a toss. So I thought of utilizing or basically taking the advantage of this time and probably walk you through regarding like how we can progress towards a responsible software craftsmanship. And this is all about you can say my learnings from the past few years on this, and also like learnings from like hands-on learnings from the current experience that we are doing at OLX, and also few of the things that our community discussions, from the community discussions, from the online conferences, all about like software craftsmanship and all this stuff. So let's move ahead without wasting any time. Okay, so whenever we hear this word craftsmanship, so usually what brings to our mind is basically the image that is basically the backdrop of this slide. It is either a sculptor or a potter who is shaping their crafts to the perfection, right? Now, do anyone of you, or probably including me, so do we picture someone writing code? If I say software craftsmanship, um, no, I think not, because software is basically valued by its utility, not its aesthetic beauty. So when we talk about a craft, it has got a beauty, it has got an aesthetic look, it's an external look and feel, and for which it has a clear impression in your mind. Yeah, this sculpture is the best because I have seen his art, right? He do very crisp sculpture and all this stuff. So this kind of things, when we try to relate to software, it's something coming into abstraction. Like it goes into abstraction, right? And we very rarely we imagine someone writing code when we say software craftsman. Um, it's deemed to be great if it solves the problem of the customer, right? Because the software is meant for the customer, and softwares deal with the customer need and in the best possible way. So what is software craftsmanship in that case? Now, I was reading a book, Software Craftsmanship by Patty McBrain. I think this is a very good book. I would recommend you to get a copy of it and probably go through the pages. It's a kind of novel of software. It's a kind of novel. You will enjoy every bits and pieces. So what it says, it says it's a kind of approach. Craftsmanship is an approach to software development that emphasizes the coding skills of software developers. It is a response by the software developers to the perceived ills of the mainstream software industry, including the prioritization of financial concerns over developer accountability. So let me give you a very brief introduction where it came from. So everybody might be familiar with the agile methodology, right? So it's not new. Like right from 1990s to 2001, these people they have been constantly working on some methodologies and trying to benchmark something on based on how we can improve the software engineering skills and probably the processes. The biggest problem I have seen, or probably most of us have seen with Agile, is basically the elimination of processes. So what Agile do is, and to be very frank, I'm not a very much defender of Agile, but yeah, just to give a comparison, I'm just uh, giving you the gist. The biggest problem with Agile that we have seen is basically the elimination of practices. So practices are somewhat compromised when it comes to delivery. Often what we do is basically we shift from excellence towards mediocrity, right? Now, why why we are reading this? So basically, software craftsmanship is a movement about preserving the coupling between practice and the culture. So it's all about marrying the culture with the best practices of software development. This is all about software craftsmanship. Moving forward, so in a nutshell, if I just want to be in a very formally, I want to explain software craftsmanship. It's about professionalism in software development, as simple as that. Now, why is it the need of the hour? So why do you need software craftsmen? So there is a very famous term in agile, or probably in our day-to-day life we see there is a term called technical debt. Uh, Sorry. Okay. So I think it was, yeah. So what happens is we have a very popular term called a technical debt, right? Now, what is technical debt? Technical debt is nothing but something that we have done right now to match the requirement or probably to match the delivery, and we're just pushing something for the later thing to be refactored or something like that. So if you notice, even the best team in the world, they will have a technical debt, right? And they deal with it every day. So every project, when it grows, it comes with more debt, and even more reason actually not to recklessly overload the debt actually. So whenever your project grows, the technical debt grows, and you just don't want to leave it with, right? You want to just overcome the technical debt, and not only overcome, but yeah, you also need to maintain the sanity of the current system as well. And also you need to tackle the continuous delivery kind of mechanism that your product that your company wants. So probably every software comes with the incremental deliveries and all, so you need to match those technical debt improvements as well as the delivery as well. So technical debt, if I talk about the bookish language, it reflects the implied cost of additional rework caused by choosing an easy solution now instead of using a better approach that would take longer. And like monetary debt, if it is not repaid, it can accumulate interest, making it hard to implement the changes later on. So that's all about technical debt. Now, what are the different causes of a technical debt? So the major causes that you can see, what causes the technical debt, major factors that contribute to technical debt, they are basically business pressures. Second, lack of process or understanding. Lack of process as in development process or probably the best practices and all this stuff. Tightly coupled components. So you have a hell lot of components and they are tightly coupled, and changing one particular component breaks the other. So and the release is just tonight. So what you will do, you will just create a patch and then release. Everything works fine. uh, Lack of collaboration, definitely. Collaboration is also important, because if there is no collaboration, then probably among the developers and also the different stakeholders, technical debt is meant to increase. Delayed refactoring. So what happens is, like, we know that there is a problem in our system, but we tend to delay the refactor, yeah, due to some probably knowledge issues, or probably ownership issues, or probably there is a poor technical leadership or something like that. So there are multiple causes, there are multiple reasons of a technical debt. Some of them I have sorted, and probably I think you might have got a relation, like, yeah, this was my technical debt and this was probably the cause for that. On the right hand side, you will see a technical debt quadrants. this quadrant is basically divided into two, I will say, matrices. One is the deliberate technical debt and one is the accidental. Accidental is something which is horrifying, that is what's layering, nobody knows, like basically they even don't know that there is a technical debt. And something that is prudent is basically we must ship now and deal with the consequences. So there is a something from reckless to prudent. And there is one very much common paradigm that you will see for reckless technical dev is basically we don't have time for design. uh, Even like you will see people forcing, yeah, we don't have time for design, just release it. So these are some of the things that can affect your technical dev. Out of all this, one thing that really you will try to relate, or probably you as a developer who is to curse, is this. So the last minute changes, right? So what happens is like on day of the release, the product manager comes and some Mr. Bean comes and he said, hey, this is not the way I wanted. I want to change this. So all these factors, combined together, it forms a technical debt, and technical debt is nothing but a big ball of mud. And that mud is basically a result of something that we have been delaying, we have been procrastinating ourselves, or probably we are decepting ourselves, and we are not accepting the reality, and probably we are moving away from what is called from excellence to mediocrity. uh, Now comes most of the people, what there are a lot of software architects and probably people, software developers, who are constantly discussing on this, like, yeah, we know that now the release train is around 15 days from now, and we need to deliver a couple of stuff. Sometimes the story points become so huge that yeah, it's very difficult to deliver, and we are burning out our oils, midnight oils, to release. Now, even if I say, yeah, there should be, I am a software craftsman, I want to deliver the best software, I know the practices, I know the methodologies. Now, will do you think this is something which is ideal? Because this is ideal, right? This is ideal thing that yeah, I need to develop my software with the best tools, best principles, best technologies. But yeah, when it comes to delivery, when it comes to software life cycle, what happens is like many a times we feel like there are business pressures, there are uh, financial pressure from the business as well, and there are lots of stuff where we are not able to concentrate much time in a very initial stage, right? So what happens is like we need to have a design payoff line. So the design trade-off line is basically an axiom. Axiom is something that doesn't needs to be proved, but there is no proof, kind of stuff. So this is a kind of subjective kind of term. It's a kind of design payoff line. So where you will see there are two curves. One is the orange curve, one is the blue curve. The blue curve is basically the one with the no design at all, no design, and people are not designing. Just like when product will say, yeah, design this feature for me for an app. Let's suppose I want to have this navigation in the app without having any further delay. You just start writing, this is extend activity and all this stuff. So you just start writing in. Initially you will see for the first 2 or 3 days you will see, yeah, I am gaining a lot of pace, right? My activity is complete, my UI is already done, I have done all those data bindings and all this stuff, and I have almost I feel like confident, yeah, everything is fine and it's a good pace. Definitely, as the curve suggests, it's a steeper at the very in the beginning. Now what happens is like as the feature grows, and as the product grows, there are incremental features to it. What happens is like the next iteration for that particular software, if let's suppose I delivered the first version in a sprint of 15 days, the next revision, it is going to take 1.5 sprint. That's where you will see the blue curve slightly declining, right? So now what happens is like had it been the other case, like let's suppose I got enough time to design my solution, probably considering some of the nitty-gritties of the feature, probably also the future perspective and all this stuff. Probably my development time and probably the feature release time for the subsequent iteration could have been smoother. This is something which is well tested, and people from different industries have tried and tested this. And what happens is like there is always, whenever there is a good design, the incremental releases are faster. So when to decide, yeah, this is the point where I can live with no design, like the design quality I can trade off to for time to market. And there is some limit above which you have to have that refactoring thing in your place, because whenever new design comes, you must tell, yeah, now my system is not ready for any incremental feature. Let's sit down, get refactor, let's refactor the code, and then incrementally add features, and that feature should ship in a very faster manner. So this is all about design trade-off line. Probably I'll share you all the links from where it came from and all this stuff. Let's go to the next one. So there is a famous architect, software developer, Martin Clark. So he basically describes about all this, the design trade-off line and all this stuff. So what it believes is basically the design trade-off line should be usually weeks. So if it is a weeks kind of stuff, then please do it. But if it should not be month. Like the design curve should not grow up till a month. So you should not leave without a design for a month. Now we know about what are the problems in the current software development cycle, and probably we also know about what is software craftsmanship is. Now how to progress towards the software craftsmanship. So what happened is, as I told you, software craftsmanship is all about dealing with all those ill practices, or probably in the software development thing. So in 2009, the software craftsmanship manifesto was laid. So there were a couple of guys who sat down and probably they thought that no, we need to have some kind of standards, and whenever we basically uh, whenever we develop software gradually, probably those standards should remain intact, and that should lead to a proper software, working not only working software but a quality software. So what does the four dimensions of quality says? Number one, not only working software but also a well-crafted software. So well-crafted software is nothing but the software that can be maintained, maintenance for the developers as well as for the customers. So the customer should get the product very fast, and also the product should behave in a very robust manner. It should be scalable, maintainable, and all this stuff. So not only working software but also well-crafted software. Second, not only responding to change but also steadily adding value. So what happens is it's actually the opposite of increasing the technical debt. So what happened is while you update the code in a system, update the new code in a system, you should also think about adding value to your old code. So you must go and revisit your old code and also see if you can refactor that to enhance. For example, let's suppose there is a new feature that is coming into place in the coming time, and you need to basically plug that feature into your old code base. So is your old code base ready for the change? You need to question that. So whenever you feel that you need to refactor your old code, just do it. So but do it in a steady manner. It's not you are compromising the latest changes, but yeah, do it in a steadily manner, and so that the code comes to your first quadrant. So basically this one. So it basically should be well crafted. Not only individuals and interactions, but also a community of professionals. So software craftsmanship, what it practice is basically not only limited to yourself. So if you have learned the craft, if you have learned the manifesto of software craftsmanship, discuss in among the communities, and also spread the awareness. Yeah, this is something that we need to do. This is our religion. This is our DNA. So what happens is it also helps developer productivity and also professional quality. And this is very important. Like in terms of, I think we are here today because of this only, and we need to empower this thing so that we learn something and make others learn as well in this. So let's grow together. So this is one of the major motto of software craftsmanship. Not only customer collaboration, but also productive partnership. So what happens is like customer do not care about like what are the practices, whether the best practices were met, what coding language have you used. All that matters to them is basically like a working software. And also after the working software, they also want that the partnership or the engagement continues, right? So to make that engagement continues, you need to deliver constantly. The quality of delivery should be consistent, and hence the aim of software craftsmanship is no different. So if you talk about normal agile thing, so even then there also you will find the customer finds a very topmost place. In software craftsmanship, we are delivering quality to the customers but with proper methodology, without any delay on that. So this is something which says not only customers collaboration but also productive partnership. The partnership should be productive. So you should get constant feedback from the customers. So whenever customers says, yeah, this is my need, or probably this is where I am facing the problem, you should solve that in your software in a very efficient manner, so that next time they don't face that kind of. So it's all about you have released a patch, your customer is happy but other customer is not. So it should not be like that. So you should gather all those requirements from the customer, and customer should be a part of your development, not it's a kind of end. So customer role comes at the very beginning. That's where design comes. So it's called the productive partnership. Now we know about software craftsmanship, we know about the manifesto of software craftsmanship, well crafted software. We need to steadily add value. Third, we need to spread knowledge. And fourth is basically the customer engagement. So we need to involve customer in our software in a productive way. Now, who can help? Who can help me in this doing this? How can I ensure that yeah, the quality of software that I am building is basically of the topmost quality, if not topmost, but at least I'm not breaking some of the existing functionalities, or probably I know what I am doing. So basically knowing what you are doing is basically something which is very important, and that's where the software craftsmanship role plays the role is there. Now who can help? Application architecture. So architecture is something uh, which is primary element of design, right? So whenever we talk about because lots of companies you will see, or lot of projects they fail uh, because of uncontrolled complexities, right? So what happens is like they start with a kind of monolith code base, or not even monolith. Like if let's suppose we're writing everything in one place and probably breaking some of the things, again doing a patch, releasing it to the production, and then again doing the same loop. Now what happens is like every architecture, what it solves is basically it helps the software with a foundation. The software has got its foundation now, and now you need incrementally build on that infrastructure, right? Now what happens if you don't have an architecture, right? So as we have discussed earlier, when you start off with a very initial phase, you see change is very easy. Like maybe the cost is $1. I'm talking about developers manpower or something like that. So let's give it a financial number, the $1 one. Let's change is easy and I can spend $1 to do it done. As we grow in time, there is unrefactored code, we have the technical debt, change becomes harder. So second stage is basically $10. Now $10. Now again product comes with some change. Now we have that pirate symbol. Yeah, just forget it. Now I need $100 to do that. Or probably the developer will say no, it is not possible. So what happens is like uh whenever you just keep on procrastinating yourself, yeah, I have lots of refactor but I'm not doing it. So ultimately the software ends. So ultimately what happens is like the software fails. So that's where the uncontrolled complexity, due to the uncontrolled complexity the software face. Now, there are a lot of common software architectural patterns that is basically relevant in today's world, and probably most of the applications, mobile applications, backend application, all are basically based on those architecture. I will give you a brief overview about the existing architecture for all those who are new to this industry. Probably it will help them to basically go and probably do some homework before jumping into the code base or probably something like that. So architectural patterns are very important to understand. As I told, it's building blocks of your software. So what are the common software architectural patterns? So we have layered architecture, event-driven architecture, and we have a microservice architecture. So most of the application you will see, they will either fall into layered, or it will be event driven, or it will be microservice architecture. In fact, it could be a combination of all the three. It could be a combination of it could be like hybrid model of them. But yeah, majorly you will find these three architecture in the software industry right now. So what is layered architecture? Layered architecture has got different units. So there it has got the presentation layer, it has got a business logic layer, data access layer, and all the data source layer. Now these layers can be multiple. It could be started from three, probably presentation, business, and data, or probably it could extend to multiple layers, right? Now, the advantage of layered architecture is basically you are separating your concerns, right? So the presentation layer is basically dealing with the UI orchestration part, and the business logic layer is basically dealing with the business logic problem statement part, or solving the basically the problem statement. What happens when you apply layer architecture? In layer architecture, your code is maintainable, your code is testable, because each layer you can test it as a different unit separately. Easy to assign separate roles. So you can assign different layer, different roles. As I told you, the presentation layer is mapped to UI. The business logic is basically solving the business problem. Data is solving the data management problem. And also it's easy to update and enhance the layers separately. So you can easily enhance and probably add incremental features to your layers subsequently. What are the cons? Cons is basically number one is basically listed at the last. It's a kind of monolithic development. So it's a kind of monolithic development that you can't avoid. So monolithic means small change can can result to deploying your entire application, right? Since your application is in a single repo. So ultimately, what happens is most of the times we find with the monolithic architecture is basically it turns into a big ball of mud. So what happens is lots of codes and codes are going into a repo, and the files are unorganized. There are duplicacies, and there is very much if the developer is not very much well aware of the layers. Probably some new developers come into the system, so it's very much difficult to maintain the sanity of the monolith architecture. Although there are tools to maintain the layers sanity, but yeah, most of the times what happens is people skip the domain layer, directly communicates to the data layer because nobody is restricting them. So this kind of stuff exists with layered architecture. Uh, so when we'll go for a layer architecture, so layered architecture, whenever there is a new application that needs to be built quickly, so instead of directly jumping into the code, think of a layered architecture model. So don't just start writing the code, start with the architecture first. So you can start with the layer architecture. Teams with inexperienced developers who don't understand the architectures yet, they can adopt this layer architecture very easily because it's quite simple. Applications requiring strict maintainability and testability standards can also go with the layered architecture. Uh, Event-driven architecture. So next architecture that we're going to discuss is basically the event-driven architecture. Now, in mobile development, like specifically, if you talk about mobile apps, most of the programs or most of the interactions are event-driven, right? So because mobile apps directly interacts with humans. So what happens if there is always a intent of the user? So user will pass an intent to the system. There is a system, or the system may itself pass an intent to the underlying software. So user can send the intent, the system will react and show an output. So it's a kind of event loop that happens inside the mobile system. So as you can see in the mobile environment, MVI is something which is quite familiar nowadays. So people are adopting MVI because of this, like, event-driven mechanism. So it's a kind of easily adaptable to complex, often chaotic environments, and it scales easily because when you know that, yeah, my users are this, and these users will interact with the system in this manner, so you can easily create events out of it and make the software react to that event. So event-driven architecture is gaining quite popularity nowadays. You can use that. It's easily extendable whenever new event type appears. So in event-driven architecture, you will find majorly three parts. One is the producer. So producer can be either a human or probably it could be a system itself. Uh, there is an ingestor, so who will ingest the event, and it will maintain a queue of events where the events will be processed in a timely manner or probably in asynchronous manner. And there are consumers who are waiting for the results. So in event-driven architecture, you will find these three roles. One is the producer, one is the ingestion, and third is the consumer part. So, what are the cons of event-driven architecture? So, as you can see, like event-driven architecture is basically intent-based and it's a kind of event-based. So, it's a more unidirectional architecture where transaction-based mechanism is difficult to manage because everything is in asynchronous manner. So, you are sending this event and probably waiting for the output, and every single entity is waiting for the output. So, acid property is somewhere compromised in this kind of way. Messaging overhead could be a challenge because your event ingestion, you need to scale that event ingestion in such a way that for large applications, the event ingestion queue will be very much high. So the maintenance cost of the event ingestion is also high. Error handling is quite can be quite difficult, especially when several modules handle the same event. So if the several modules are waiting for the same event to do, and if the error occurs at one point, then it's very difficult to manage, error handling that. It's ideal for asynchronous system with unidirectional flow. Whenever you find next kind of stuff, so most of the mobile application you will find the navigation are unidirectional. You can apply that where individual data blocks interlink only few of the many modules. So there is a very kind of isolation, separation of concern are already there. You can use that, and it's ideal for user interfaces. So whenever you are designing an user interface, where there are navigation, where there are actions, where you can see a lot of humans are interacting with the screen, you can probably adopt for a the event-driven architecture. Third architecture that we discussed is basically the service-oriented architecture. As the name suggests, service-oriented architecture is basically dividing your responsibility into different services. So it has got a different names. People call it microservice, people call it microkernel, somebody call it plugin-based architecture. So it's all about distribution of roles. So it's a kind of plugin-based pattern, and it consists of two main components. One is the core, and other one is the plugin components. So if we talk about the diagrammatic representation, so in type of if in form of mobile application, so you have an app module and you have a different modules. Like you might have heard about a dynamic representation. So there is a video player which plugs into the app. There is a user profile. There is a feature settings. There is a video player which plugs into the app. There is a user profile. There is a feature settings. There is a code. Uh, okay. So what does service-oriented architecture provides? It can provide platform independence. So each service can coexist in isolation. So it doesn't depend whether the app is using some predefined is in some predefined platform or probably in some other. So the service-oriented architecture gives you platform independence. Easier to test, more reliable. Easier to test as in you are maintaining those different features into different repos probably, and each repo is comparatively smaller than a monolith, so it's easier to test and hence it's more reliable. ability to reuse codes. So what happens is like, let's suppose you have a video player module in as a microservice. Now let's suppose you have different apps in your company. So probably what you can do, you can just plug in that video player in your existing app, probably in a new app, you can just plug in. So ability to reuse codes is already there. Parallel development can also go hand in hand in this, because services are independent. So everybody, a set of bunch of developers can work on one microservice, another can in another one. Scalability, obviously, you can scale because every architecture are every module are working in isolation, so you can scale within itself. So scalability is not a problem in this. But service-oriented architecture, there are cons. What happens is like unmanaged. So I have seen some applications who says, yeah, we follow microservice architecture. But if you see, there are a hell lot of repositories. So it's very difficult to maintain them. And it requires thorough analysis actually. So it's not like microservice. People are going with microservices. Why not my app? So it's not like that. So whenever there is a need, you should go with microservice architecture. Else, what happens is like it accumulates lots of repos and is very hard to manage, especially for small teams. It's very hard to manage. Ideal for like plugin modules, as I told. Testing is easier if you want to have isolated testing. You can reuse. You want to reuse your code, and also you want to provide those modules on demand. You can go for uh, microservice architecture. Now we know about software craftsmanship. We know about the principles. We know about the basic foundation, which is the architecture. Now, which architecture do you choose from? Like if you were a craftsman, so which architecture you will choose? So it's basically, it depends, right? Because what happens is basically every architecture comes with its own pros and cons, and also every problem statement or every feature requires a different set of thinking, or probably different set of mindset to solve that particular problem. Now I can't say that the monolith architecture is bad, or probably the event driven architecture is good, or probably I will always go with a microservice. I can say that because every feature comes with its own limitations, own requirements, and own problem statements to cater. So what should be the motivation while choosing the architecture? Number one is cost. So am I okay to bear the cost of maintenance of that architecture? If the answer is yes, go for it. Time to market. So let's suppose I have a release in next 2 days. What should I do? So I'll go with a monolith probably, because I don't want to invest much time. I know that these are the concerns. Let's go with a monolith first, and let's see if we can go it into reusability thing. Because at the very first stage, like the foundation is must. So whenever there is a time to market crunch, go with a monolith. Number of users, current and futures. So how many users are going to use that? That is also a concern, because scalability will depend on the number of users. If it's a handful of users, I think a monolith is the best one that you can use. But let's suppose you want to have a number of users using that, so probably you might consider going with a microservice probably. Probably because you are having different apps, and you want to reuse all these apps. And also what you want to do is, if the number of users are high, probably the scalability will be it will demand more scalability and also the maintainability. Probably you'll go with a microservice architecture, because deploy once and it will reflect in all the other apps. So these kind of things, decisions you can take. Level of independence. So if you're building a software and that software is supposed to be a software to be used in multiple apps, or probably in multiple environments, not environments, probably in multiple apps, or probably in multiple scenarios, probably go with a microservice architecture. So these are some of the decision making criteria while whenever you are about to choose a particular architecture. uh, Android specifically, ecosystem is moving very rapidly, right? And it's growing every day. Every day you'll find something new coming in, right? So now if you talk about comparison between all these architecture, like a monolith approach basically forces your architecture, right? So whenever because there is a clear dependency among the modules, so your monolith architecture forces the architecture approach. It is not flexible enough. Now if you talk about Android specifically, every day new things are coming. We didn't have view models a couple of years ago, right? Now the view model is something that is thoroughly accepted across the developer community. Now, what happens is like if you are into a monolith, then there is always a reluctancy, right? Because uh, nobody wants to delete his own code, right? So when I started my development, I felt very much sad when like my manager told, yeah, this is all crap, delete it. So it's very difficult for us to digest that yeah, my code is bad. So whenever you go with a monolith, what happens is like it forces the architecture, and other new things are very much like susceptible. It's very much people are reluctant to change that, right? So in case of that, probably what you can do is you can, if you want to in specifically in Android, it's high time that we go into a kind of microservice architecture, my favorite, because each microservice can be built in the latest technology trend, and probably I can have a very much less coupling with the monolith. So in terms of Android, I would say a better approach is basically going with a microservice and expose that microservice as a reusable component, and like you can adapt to all those latest technology trends, probably programming language and all this stuff. But the basic thing remains the same. We should not build fighter jets to buy groceries from a mart on the opposite road, right? Because you will not be building fighter jets. So keep it simple. Basic things that you should take into consideration while designing apps or probably designing the architecture. There are different levels of design, right? So there is a software system, and you divide that software system into different subsystem or packages. uh, Next is like dividing itself, the sub package you divide into different packages, then you divide into different routines or probably some use cases, and within the class itself. So these are some of the levels of design that you can think of whenever you are just starting to write a particular piece of code. So what does it suggests? So it suggests like architecture that you choose should be of minimal complexity. The ease of maintenance should be high. There should be very loose coupling. You should not be having like more dependent components, or actually everything should be loosely coupled. There should be high cohesion. So there is high cohesion. So these are some of the, like, whenever you feel like yeah, there are lots of architecture, which one to choose and which one to not, stick to the basics, I would say. So your solution, any solution you make, it should be of minimal complexity, it should have a very low maintenance cost, there should be a loose coupling, and there should be high cohesion. I'll skip this because I've already talked about responsibility separation and the bounded context, because responsibility separation is basically tells you about like how each layer are independent of the other layer, and it's a kind of outside to inside dependency. Everybody knows about the clean architecture code. Now, what does a good software architecture, like what does a good software architecture demands? So there are some of the key principles. So if you see in the most basic form, mobile app architecture, it embraces a set of patterns and techniques which developers follow, they should follow to build a fully structured application, right? So hence there should be some key principles and some key practices that is relevant not now but also from like since the inception of the word software engineering has came. So there are some of the key principles and there are some key practices that we should follow in our journey towards the software craftsmanship. So I will take some of the time in principles and then we'll move into the practices. Number one, very famous, solid principles. So solid is basically the acronym of single responsibility principle, open close principle, list scope substitution principle, interface segregation principle, and dependency inversion principle. So solid principles are something that you should be taking care of because this itself is a very huge topic, and probably these are some of the principles that you should follow while driving your solution. So whenever you write a class, probably you should see your class is not doing multiple stuff, your function is not doing multiple stuff. Open close principle, what it suggests is basically you write a code and there should be only one reason to change. That means your code is basically doing a single stuff, and it if it is has to do some extended functionality, extend it. Don't just create a mesh on the same function or a class. List scope substitution principle is like where your immediate descendant class should be easily replaceable with the parent class. So son of a Don should replace the son of a Don. It should not be like the son of a cook is replacing the Don. So it's simple as that. Interface segregation principle is basically segregate the interface. Don't ever uh, force a client to implement something that it doesn't want. So let's suppose we have a printer and there is a advanced printer. So don't enforce a client who just demands a simple printer to implement the scanning functionality, right? So this all about the interface segregation principle. Dependency inversion principle is like higher modules, dependencies should be provided from the higher modules to the lower modules instead of direct dependency. So this is a kind of dependency inversion. You are already familiar with Dagger and all this stuff. So Dagger is just a medium to provide the dependency inversion principle. So there is a concept called dry. Do not repeat yourself. So one we read solid, second is the dry. So less code is always good. That is basically the simple funda of this. Now, what dry principle says is basically you should divide your code into different pieces, and that code should not be repeated everywhere, right? Because what happens is like whenever you repeat your code, if their particular bug comes in a particular set of code, and that code is repeated across your entire system, then it's a collapse, right? So do not repeat your code. Wherever you feel like that this code can be extracted to abstraction level, just abstract it, right? So this is what some of the basic principles suggest. Second is like KISS. It's a keep it simple, stupid. So don't over engineer your code. It will just add additional problems with it. So keep the problem statement simple, and also the solution simple and straightforward. It will help you to find bugs a lot easier. So there is a convention each method should never be more than 40-50 lines. So it's simple. Yagni. So Yagni is something that is very popular. It came from Agile actually. So what? Because Agile always aim into working software and not onto the practices and all this stuff. So what it suggests is if you're not going to need it, don't build it. So it's a kind of terminology that came from Agile. It also applies for software craftsmanship as well, because you are not going to create something that is going to be used 100 years later, right? So don't be that over enthusiastic to create that. So just be stick to the basics, stick to the problem statement, solve it, you're done, and a best possible way. Now, what are the key practices that a software craftsmanship should follow? Pair programming. So pair programming is nothing but programming in a pair. You are not working in isolation. So if you see the picture, there is a constant thing we. So how do we? What should we? How can we? So it should be a we rather than I, because collaboration with co-colleagues are always good. And you never know, because when you develop a code, you have your own mindset. There are actually three mindsets. One is basically what you think, second what the other person think, and third what the actual the problem is. So there are always a three mindset. So better to have two than have one. So that's where the pair programming comes. But this is not pair programming. People are just tending to fight and over some indentation and all this stuff. So this is, so please avoid that. Dojo katas. Uh, Practicing dojo katas is really helpful. To be very honest, I was not a very big fan of dojo katas before I joined OLX. So there was a visit from our overseas counterpart. So they came and they proposed this dojo katas, and I really felt it very much promising. So what happens in dojo katas, for all those who are very much new to this term, is basically there are two moderators and there is a group of people. There is a round table, and we have a 5 to 7 minutes. There is a problem statement basically, and what happens is like there is a stop clock, and every 5 minutes the laptop basically circulates from right to left. So every person gets some chance to write a code for a particular problem, a very simple problem. And then immediately next 5 minutes, the second person will immediately continue from the part where he left. So what happens is like you get to know your shortcomings. You also get to know about what others is thinking, and also the other is also, oh, this I have not thought, or probably the other will feel, yeah, I know a better way to do that. So this kind of dojo katas helps a lot to like to gain all those expertise, and it's very fun. uh, if you haven't tried it yet, please try it. Last and the monster piece is basically test driven development, and this is something that is a topic of debate not only today but right from the day of inception. So, what people mostly have a misconception about test-driven development is like, I already know the design. Why should we? Why should I go for a test-driven development? I know monolith, I know microservice, I know event-driven direction. Why should I go for a test-driven development? Now, if you talk about test-driven development was is basically a kind of perspective, like how I believe test driven development is. Like test driven development basically keeps me concentrated basically to the problem statement. I don't litter here and there when I write a test driven code. So test driven development, you should go for it when you think that because it test driven development has very a thin line between while where whether test driven development helps you in design, or probably how it is going to help you in architecture things. But there is always a thin line between the test driven development and the architecture. I'll show you in the next slide how it is done. So basically what happens is like classic school triangulation. So this is basically a classic school of thought. There are two thoughts. One is basically the classic school, and one is the London school. So classic school triangulation, what it say is like you should not write code that is beyond that problem statement. So write enough code that should pass your test, right? Now, where does your design starts? Now, if I say I started off with a unit test, right? And I started off with test, and that test basically fails. Now, after that test fails, what I do is like I go and fix my code and then go into the green state, right? Now, only you write enough code that helps you to achieve that green state. Now, after the green state is achieved, there comes the design part. Like the refactor thing is basically the design part. So test driven development is not contributing to the design. Design is at all is totally different, right? Because what happens is like test driven development is just allowing you to basically write code that is necessary. So remember that Yagni. So if you don't want to need it, don't. If you don't need it, don't create it. So it will help you to create minimum code. Refactoring, after the refactoring thing, the design parts come. So all those learnings that you have from the previous slides, that you can apply in the refactor. Now, after you refactor, who will give you the assurance that the thing that you refactor will work fine? Because your test was earlier green, now you again execute the test, you will either get a red or a green. So when you get a red, you know that the refactor that you did, or probably the design that you did, that broke something. So what you do, you again go make it green, and then again see if there is any scope. If there is no any scope, your software is done. So likewise, this is a triangulation of methodologies that you need to perform while doing the TDD. So now you know about the all the what is software craftsmanship, what are the different why we need a software craftsman, what is the technical depth, how we can harness the technical depth, how we can what are the different manifestos of software craftsmanship. the architectures, basically the practices, the tools. Now, what should you do now? Like basically, we know all this stuff. What should you do? Like an aspiring software craftsman, when we should together raise the bar of professional software development by practicing it. We should practice. So practicing is something that will uh, tell you, or probably that will give you a nudge in your head. Yeah, this is something that I should be doing. So, and also, like, help others to learn the craft. So you should not be confined to yourself. Practice, learn it, and share it. There is a link, manifesto, the softwarecraftsmanship.org, where you will find all the manifestos, and there are thousands and lakhs of people who have signed in the oath for software craftsmanship. Just go to it, sign in. After that sign in, you will feel better. Trust me. The moment I sign in that thing, I felt myself more accountable. I used to see things in a different manner than I used to see things earlier. Do it and sign it. So these are all references. Everything is done. Thank you. So myself, so you can connect me over any medium. I am in LinkedIn, I am in Twitter, I am in Insta, everywhere. So this is me. I currently lead a team in OLX India. So it has been around a wonderful journey of 1.5 year in OLX. And what OLX gave me was basically a platform where I could explore myself, explore my capabilities, explore my limits. So it's not like I have gained that pace where I can say myself to be a software craftsman. But yeah, I am gradually progressing towards it. And as I am progressing, I am sharing things with people and making people understand the need of software craftsmanship. Thank you very much. I think we can open questions now.
Yeah, thank you, Hitesh. I think it was great insights into software craftsmanship and software architecture in general. So we'll take questions now. I'll just share my screen.
Yeah, just a second. Yep,
Yeah, so I hope everybody can see my screen. Yeah,
yep,
so what we'll do is we'll take questions for 10 minutes, as much as we can cover, and then we'll open the floor for a short networking session. Okay, so the first
yep.
question is, how often should we refactor and how much refactoring is too much?
Okay, so it's something that is a very valid question, right? Because when you comes to refactoring and you see a very hell lot of old code in your existing code base. So how often should you refactor? How refactoring is too much? That again is actually relative, and also you can see the amount of time that you have. But what I will say is, whenever you are done with a particular project, right? So let's suppose I assume that most of us are using sprints. So let's suppose we have a 15-day sprint. Now, what you can do is you can have some slot available for yourself within that sprint itself for your technical debt, right? So for overcoming the technical debt. Now, there is not any exact percentage of how much you refactor, but yes, sooner better. And how much you can refactor, it will depend how much test cases do you have in support to validate them. So if you don't have test cases, I would say go baby steps, go one by one. Don't refactor the entire module and just replace it. Go baby steps. I hope I have answered your question.
So the next question is, what must be the way to communicate that you need time to refactoring?
Okay, very good question. So every now and then, actually, whenever I face this, question, it's very hard. Actually, very hard. So it's very hard to communicate that you need time for refactoring. But one thing that you can say is whenever you refactor, what happens is like as you can see in my slides also, I have told you there is a graph. Like if there is a good design, it has been proven that whenever you will be incrementally adding features, the time to market will be very less, right? So whenever you are going to propose something to your let's suppose manager or probably the higher authorities, who are basically in direct control of you, or probably the development. What you can do is you can just give them references, right? Because there are some proven references. You can give them references, do some baby steps, create some POC around it, refactor around it, and see if you're getting some results, and project those results. And definitely it will take time, so don't assume that you go and they will give you time. They will not give you time. So you should do something, wait for the results. If the result comes, then probably you have some data you can easily communicate, but always communicate with some data. Yeah. Next.
Okay, so next question is readability versus performance. Can they coexist? And if not, which one should be given higher priority and how to balance them?
I think readability and performance. So if I talk about performance, so application performance is something that, yeah, obviously, if a method name is juggled up, that doesn't matter whether the performance is basically low or high. That doesn't. So there are two independent stuff. But what happens is, like, if you're properly designing a software, so what happens is, let me tell you, whenever you design a software, you are not designing it for yourself, right? So you are designing it for somebody else, and that somebody else is basically your company. So your company is your customer in that case, right? So what happens, let's suppose your company's let's suppose what happens is, like, uh, 6 months down the line, let's suppose your company has an audit, and probably you are asked that, yeah, tell me within, like, very short amount of time, why this method, why this functionality is not working. Now what happens is, like, at that time, your code is very robust, right? Your code is performing very well. You are not present. One of your teammates is there, and he just open up your code and he sees some 0 and 1. It is not doing that stuff, right? So if you talk about the history of computer engineering, it started with the assembly language, where everything is, like, 0 and 1. Then it came, like, instruction level and all this stuff. But ultimately what happens, you have now a kind of behavioral naming convention, right? So but just by looking at the on create of a main activity, you know that this method is supposed to be creating an object. Whether you overload that on create to basically reduce the performance, or to increase the performance, or probably decrease the performance, that is totally upon you. But yeah, they can coexist. It is not that you can't write good names and compromise performance. They can exist together, and there is nothing like priority. As you practice, it will come automatically to you.
Right. I would also like to add my 2 cents on this question. So I usually like to follow 80-20 rule for this. So 80-20 rule states that only 20% of your code will be responsible for 80% of your performance bottlenecks. So
Yeah.
if I have to compromise readability, I'll only compromise for 20% of my code.
20%.
Yeah. Okay,
Very
so
well put, Abhishek. Yeah.
we'll take next question. What are your thoughts on the evolution of over engineering as a result of architecture choices?
As I told you, we don't build fighter jets to go to the market.
Right.
So we usually walk or probably take a rickshaw. So the answer is that.
Yeah. So follow case.
Yep.
Is MVI an event-driven architecture? How it is different from layered one like MVVM?
Okay, so if you talk about event-driven architecture is basically it considers even in the slide you can see whenever there is a human interaction, you can term it as an event, right? So let's suppose a gaming app you have. So there is a human interaction. Every now and then user are interacting with your system. So MVI is the only architecture I would say where user has got a specific place. Like, you will not find a single architecture where you will find user as a layer. So basically user is something as an intent. So user directly is a kind of implicitly it applies an intent. So yeah, the MVI is an event driven architecture. How it is different from MVVM? MVVM is actually you can build MVI using MVVM, but MVVM is more into what I would say, it's a kind of observable kind of stuff. Wherever you can, MVVM is not unidirectional. MVVM can be bidirectional, but MVI is always unidirectional. So there is always a starting point and there is an end point. You can't go back. So it's a kind of linear. So linear architecture, I would say, is different from MVVM.
Okay. Just a second. Yeah. So next question is how to choose between performance and maintainability and how one should benchmark these.
Okay, so choose between performance and maintainability, as in like there are apps, because if I talk about maintainability, that means my app is having a architectural pattern, so it's following an architectural pattern. Because if it is not following an architectural pattern, it is every component is depending on every other, and it's creating chaos, right? So even if your app is a very high performing app and there is no architecture around it, it's very difficult to basically adopt new changes. Uh, as I given you an example, like let's suppose you have a feature in a particular sprint, you just completed it in 15 days. The next immediate feature that needs to be developed, that is basically on the top of the existing feature, it takes 1.5 sprint. So this is something that where you will feel the need. Yeah, that means the architecture that I chose for the previous solution was not correct, or probably that is, even if that was performing well, but that is not maintainable. So likewise, you can have a kind of comparison among the time to market, the cost, and also the like performance and maintainability always goes hand in hand. But yeah, to benchmark this, there is always one factor, that is basically how incrementally you can deliver changes to your customer. Hope Niharika have answered this.
Cool. Next question is how monolithic layered architecture or event-driven architecture, etc., is mutually exclusive, especially in the context of mobile app development.
Yeah, especially in the mobile app development, like monolith, layered, and event-driven architecture. So in mobile app development, you will see a kind of mix and match actually. So they are not mutually exclusive. If you talk about, because as I told, in Android specifically, like things are coming and going like anything, right? So what happens is like every time a new feature comes, even if your app is a monolith, you are at all liberty to add new modules to it, expose as a new microservice, or probably in fact inside that module you use an MVI architecture on event driven architecture on that. So you are flexible of using all levels. They are not mutually exclusive. Uh, even if your base app is a monolith, you are at all liberty to use layered architecture, event driven architecture, and probably any new architecture that comes into picture. So from mobile app development, there should not be bifurcation, but yes, you should know about, like, it's all about choosing the new architecture for your new feature. So whenever new project comes in, there should be some, you should know that what a monolith is having, what are the pros and cons of a monolith, what are the pros and cons of a event driven, and then choose your architecture wisely from mobile app development perspective.
Great. Mm, Next question is, and this is the last question we'll be able to take today.
Yeah.
Say my current app is on MVVM or MVP, and I learned MVI and find it a perfect fit for the application, and it's much better than other architectures. Should I update?
The answer is it depends. So you learn MVI and find it a perfect fit for the application. It doesn't mean that MVI will go with all other use cases, right? So it depends. So it totally on the use case. You need to see what MVI is having. MVI is help. Does MVI is helping you to solve your purpose? If you're getting stuck at the very later stage, it will be a problem for you. So it will again raise the technical debt that is not entertained. So you need to reconsider this, and probably you need to choose wisely on that.
Right.
My answer is not always no, not always yes.
Right. The cost also has to be refactored in.
Cost, yeah, cost is also there. Yeah.
Okay, great. So these are the questions that we were able to take today. Um, So, so the question that we were not able to take, you might want to directly contact Hitesh on
Yeah,
his social media
please.
handles,
Yeah.
and he'll be able to help you. Um, so now I'd like to thank everyone for joining, and thank you Hitesh for such a great presentation and such insights. Um, I'll be circulating feedback form links in chat, and now I open floor for everyone, so you can unmute and you can discuss anything that you would like.